So the cross product is the third type of multiplication we're going to do with vectors. The first one was scalar multiplication, where you take a vector and you just multiply it by a single number. The second one was dot product, where you take a vector, multiply it by a vector, and you want a number as your answer. Cross product is for when you want to do multiplication of two vectors. Multiplication of two vectors. With a vector as your answer. So what this ends up generating is a third vector that is perpendicular to both vectors you put in. So if I were to try and cross this vector, m is 3, 2, -1, and p is 7, 4, 3. When I'm done, I will have a vector that is perpendicular to m and perpendicular to p. So how do you accomplish this? Well, there's a great big formula you can look up, or you can do it by patterning. So the first thing I'm going to do with this is I'm going to write an x like this, a y like that, a z like that. Then I'm going to write the coordinates of each of my vectors under the appropriate thing. So 3, 2, -1 goes here, and 7, 4, 3 goes here. So what I'm trying to calculate in this particular setup is m crossed with p. You notice that m is first, so m is on top. P is second, p goes underneath. It turns out that this operator is not commutative. It's not the same answer if you go backwards. So we're going to do m cross p first, and then we're going to try and calculate p cross m so that you can see that they're not the same. So next little step here, I'm going to copy this x column to the end, because I'm going to need it in a minute. Alright, so to do this, to get your x coordinate of the answer we get, so let's see, m cross p equals. To get the x coordinates, I'm going to ignore everything in this column, and I'm going to use the y and the z to generate it. And the way you do that is you take the y value of this column and you multiply it by the z value of the other. Then you repeat the, so let me write that down, 2 times 3. And then you subtract from it this y times that z. And you can see there that in this little activity, I've drawn a little cross. To get my y values, I'm going to ignore this column. This is why I copied the x, so that I didn't have to sort of wrap around. I take this x times this, or this z times this x, so -1 times 7, subtract this one times this one, 3 times 3. And to get my z coordinates, I ignore the z column and use only the x and y. Top to bottom, left to right, 3 times 4. Subtract, bottom to top, left to right, 7 times 2. So the only thing left then is to actually do the calculations here and see what I get net. So m cross p should be 2 times 3 is 6. -4 times -1 would be +4. -7, -9. 3 times 4 is 12. 7 times 2 is 14. So m cross p should be 10, comma, -16, comma, -2. So this vector I've just generated, and then lost the lid for my yellow marker. This vector I just made should be perpendicular to both m and to p. So it's a good idea to check. So try m dotted with m cross p. So m was 3, 2, -1, and m cross p was 10, -16, -2. So 3 10s would be 30, 2 -16s would be -32, and -1 times -2 is +2, and that equals 0. So this vector is perpendicular to that one. Excellent. Try the other one. P dot m cross p would be 7, 4, 3, dotted with 10, -16, -2. 7 times 10 would be 70. 4 times 16 is 40, 64. And 3 times 2 is -6, which does equal 0. So we know we did it correctly because the answer I have here, right, this vector I generated, is perpendicular to both of its inputs. Now that's it. That's all we're doing in this section, is figuring out how to do this cross product. So I'm going to try this again, but I'm going to do the other operation. I'm going to do p cross m, so we can see that the answer is slightly different. All right, so to do p cross m, I'm going to need my chart, x, y, z, and then a copy of the x column here at the end. To have this vector, or my answer, turn out as p cross m instead of m cross p, I need to write the p vector in first. So 7, 4, 3, 3, 2, -1. Copy the x column. All right. So to do my x values, I ignore the x column and use only the y and z. So I'm going to do 4 times -1, subtract 2 times 3. To do my y column, I ignore the y and only use the z and x. So it will be 3 times 3, subtract -1 times 7. And to get my z, I ignore the z column and use just the x and y. It'll be 7 times 2, subtract 3 times 4. So 4 times -1 is -4 minus 6. 3 times 3 is 9. Negative is positive. 7, positive 7. 2 times 7 is 14. And 3 times 4 is 12. So I end up with -10, 16, 2. So if you've forgotten what the answer was to this question was m cross p, I left it up there. It was 10, -16, -2. Those are the same numbers, but the signs have changed. So it turns out that m cross p is the same as p cross m, but you've changed the sign. Now, if you change the sign of a vector, you've changed its direction. Instead of going that way, it goes that way. Remember that from the very beginning. So these cross products follow a thing called the right hand rule. Basically, you have to take your right hand and you point your fingers in the direction of the first thing that you're using, your first vector, and then you fold your fingers and point them in the direction of the second one. If you do that, your thumb will be pointing in a third direction, right? This is perpendicular to this, which is perpendicular to that. This is the answer to the question you've done. So if you do them in a different order, right? Instead of doing M cross P, if you did P cross M, you notice I have to turn my arm in order to do that. So it forces the direction of these things to change. So give that a try, and you must use your right hand. If you use your left hand, it ends up wrong. Try turning your hand in one direction and cross it, and then try this way and then cross it in that first direction. You'll see that your thumb has to turn. It's always fun during university exams, especially if you write them in a big gymnasium. You can sort of stand and watch everybody working, and you can always identify the physics majors and the engineers, because they're all sitting at their table, scratching their heads, doing this sort of thing up in the air, trying to figure out their right hand rules, while all the English majors are instead pulling at their hair, trying to remember all those facts about Shakespeare. Suckers. What are we talking about? Anyway, cross product. So all I need you to be able to do in this section is to employ this algorithm. So you're going to take one vector, put it here, the other vector, put it there, copy the x, and then you do this crisscross pattern in order to generate your coordinates. As always, it is an excellent idea to take your finished product and dot product it with the originals to make sure you get 0, because by definition the answer to your cross product must be perpendicular to both vectors that you used in the first place.